Okay, so good afternoon. We are the Central Park team, and this is our Garbage Classifier project. Our motivation was the global recycling crisis and the growing amount of recyclable matter in landfills. We realized that despite the bins and option to recycle, many people didn't. We hope to create an AI that would aid humans in making these decisions to preserve the environment.
To collect our data, our group actually got fairly lucky. We were able to find a ready-to-go data set that fit our needs on a site called Kaggle. This essentially helped us a lot because it eliminated the step of manually finding the images. This also allowed us to get ahead because we were able to directly import the images that we got from Kaggle into Label Box and then start labeling. We labeled the images into 6 categories: cardboard, plastic, glass, metal, and paper, and also general trash.
When we put the data set into label box, we noticed that some images were not as good as others. These included things like cardboard, and it was just a flat piece of cardboard that looked like any normal tabletop. We made sure to take out these kind of images because this could influence how accurate our classifier was when you would input an image. There were also things like paper and trash. If it's like a crumbled up piece of paper, it could kind of look like trash. So we had to go back and relabel them to make sure that they were accurate.
So in terms of our algorithm and training, we used Joseph Redmond's YOLO repository, and that provided us with the necessary algorithm and the training schematic to build our object detector. And that was very thoughtfully provided to us on GitHub. And before we began training, all of our data was downloaded from Labelbox, the data that we had manually labeled and split into our respective 6 categories. And then we wrote a script to split them into the training, validation, and test sets. And to evaluate the error of our trained model, the IOU, or the intersection over union, was computed between the predicted bounding box and the actual bounding box, or the ground truth of the images.
Our model achieves an accuracy rate most of the time of over 95% due to the large amount of data that we used during the training. We ran into a problem where at first the classifier would put the same label over the same region in the image multiple times, and to fix that we used the non-max suppression, which suppresses the less likely bounding boxes and keeps the best one with the highest confidence level.
Okay, so the first major difficulty that was encountered was mislabeled data, because, well, how do I phrase this? Because in label box, we had different categories. So metal would have like 200 labels, and then cardboard would have 200, and then glass would have 150, but something like trash would have like 95. So that's a great discrepancy between those amounts, which would make it harder for the program to learn what trash looks like. So to fix this, we had to go back into label box and fix some labels. And because we used a Kaggle data set, we were able to go into the file and check, and each image in the data set would have a name that would tell it what it is. So trash JPEG. So we would check. So we would go back and then make sure that the name correlates with what the label is. And another difficulty was the fact that for a time the program was classifying images incorrectly, and really incorrectly. We would look at a metal can and say that it was a bike, and then this turned out that when you were calling the AI, it was using the incorrect weight. So we had to fix that and give it correct weights.
Finally, the first lesson we learned was that preparing data takes up a large portion of time in creating an AI. Although in this project, all of the images were downloaded off of Kaggle and there were 6 people labeling, it still took a while. We also learned that in the real world, code usually doesn't run perfectly, so much time is also spent debugging and fixing errors. For example, our environment was initially not set up correctly, so there were some setbacks. A third lesson was that the type and number of training images determine how well the program works. For example, we didn't label images of trash piles, so our AI is unable to categorize an image as being more than one category. And lastly, we learned that AIs aren't an automatic human replacement. They're prone to error as well and will likely be used to augment humans. That concludes our presentation. Thank you for listening.
And now I'll just quickly demonstrate what our website looks like after it has been deployed. So here is our garbage classifier, and we have our start classifying button out in the middle of it, so you can immediately start testing our product. And we have a bit of an overview of our project, also just further elaborating on our motivation for it. And also here is our wonderful team and a photo of us in the middle of one of our lectures, and also the workflow and some acknowledgements. Just wanted to thank Logan, our CV team instructor, and also of course, Michael, for their continuous support throughout the entire process. And also a huge thank you to Kaggle for providing our data for us. That saved us a lot of time. So now I'll just quickly demonstrate what our product looks like in action. Let's start classifying, test images. Let's try a piece of tinfoil. And we'll classify that as metal. And if you hit learn more, then we can learn more about why this, how this product works, and also a brief description on what happens when certain things miss. So for example, if we were to classify a pile of trash as opposed to an isolated piece of trash, our product unfortunately has a bit of trouble identifying that because it doesn't know to differentiate between these different regions and like think of them as like individual objects. Instead, because it was only trained on isolated objects of trash, it just considers this one big mass of paper. And so that's just a brief description of our product and why it sometimes misses. Thank you.
That is awesome. I also really like the real world applications for that, for garbage data set. I can very clearly see the motivations.